In Chapter 11, we're going to discuss probabilities. Now, probabilities is simply an educated guess on whether an event will happen or not happen. To figure out probabilities, the first thing we're going to do in the first 3 sections is look at different ways that we count things. In section 11.1, our concern will be on what we call the fundamental counting principle. It's a very simple principle. And we'll start off with looking at 2 groups. Let's say that you want to choose an outfit from 2 jeans. So you have a pair of blue jeans and a pair of black jeans. And you have 3 t-shirts, beige, yellow, blue. So this tree diagram, and it's called a tree diagram because it looks exactly like a tree, shows all the possible outfits that you could form with 2 jeans and 3 t-shirts. So let's say that you decided to choose your jeans first. So you can choose a pair of blue jeans. Once you've chosen your blue jeans, you can pair it with a beige t-shirt, a yellow t-shirt, or a blue t-shirt, which gives you 3 possible outfits. Now let's say that you chose the black jeans. Then you can choose to pair the black jeans with a beige t-shirt, that's one outfit, the yellow t-shirt, another outfit, or the blue t-shirt, which would be your other option. And that gives you 3 possibilities. So all you have to do is simply add these to get a total of 6 possible outfits. If you have a tree diagram, all you really have to do is just count the bottom 1, 2, 3, 4, 5, 6 to get the 6 possible outfits. Does the order that you choose matter? So let's look at this diagram again. And let's just say that you decide you're going to choose your t-shirt first. So you could choose the beige t-shirt, and then you would pair it with either the black jean or the blue jean, which would give you 2 possible outfits. Or you could choose the yellow t-shirt and then pair it with either the black jeans or the blue jeans, which would give you another 2 outfits. You could choose the blue t-shirt, pair it with the black jeans or the blue jeans to give you another set of 2 possible outfits. So when you add all these up, you get 6. And what this shows us is that the order that you choose, either the jeans or the t-shirts or whatever your items are, the order that you choose doesn't really matter because this is all addition, so it's what we call cumulative. Here's the formula for the fundamental counting principle. So let's say there are m items from one group and items from another group. So the total number of 2 item choices is simply m times n. In our previous example, we had 2 jeans, 3 t-shirts. So when you just multiply 2 times 3, you get 6. Or if you do 3 t-shirts times 2 blue jeans, you get 3 times 2, which is 6. So order doesn't matter here. Example 1, we have a restaurant. It offers 9 appetizers and 8 main courses. In how many ways can you order a 2-course meal? Simple. You just take the 9 items in the appetizer group times the 8 items in the main courses, and you have 72. Oh, really simple. Let's do one more example. This is a semester that you will take your required psychology and social science courses. Because you decide to register early, there are 7 sections of psychology from which you can choose, and there are 5 sections of social sciences that are available, and these do not conflict with each other, so you can take them both. In how many ways can you create a 2-course schedule that satisfies the psychology social science requirement? 7 times 5. 35 ways. So it works with two groups. What if you have more than two groups? Well, if you have more than two groups, it's the same rule. You just multiply all the choices from each group. For example, a pizza can be ordered with 3 choices of size, small, medium, or large. So one group would be the size of the pizza. 3 choices of crust. So the other group would be the crust, thick, thin, thick, or regular. And 6 choices of toppings: ground beef, sausage, pepperoni, bacon, ham, or mushroom. So how many different one-topping pizzas can be ordered? You have small, medium, or large for size. So you have 3 choices for the size of your pizza times 3 choices for crust times 6 choices of topping. Simply multiply to get 54 possible one-topping pizzas. In example 4, we have a certain model of car, and it has the option of 10 possible colors. So one group would be the colors. Electric or gas powered, so it can be powered by electricity or it can be powered by gas. So there's 2 choices on how it's powered. With or without an onboard computer, that's another choice. With or without GPS, that's another choice. So in how many ways can this car be ordered in terms of these 4 options? Well, you have 10 choices on color, times there's 2 choices on how you're going to power the car, times 2 choices for the onboard computer with or without, times 2 choices for the GPS with or without. Multiplying all this together, I get 80 ways that I can order this car. You see, it's fairly simple. And let's go through our last few examples. Example 5, let's say you're taking a multiple choice test that has 20 questions. Each of the questions has 4 answer choices. 1 correct answer per question. If you select one of these 4 choices for each question and leave nothing blank, in how many ways can you answer the questions? Okay, so this is a little bit trickier because each question is its own group. Each question has 4 choices. So you're going to have your first question, second question, third question, fourth question, and so on. So when you look at the first question, there are 4 choices. The second question, there are 4 choices. The third question, there are 4 choices. So each one of the questions, since it has 4 choices, each question is its own group. You would just multiply all of these. And there are 20 questions. So that's going to be, it's not 20 times 4. Remember, you're multiplying 4 by itself 20 times. That's actually 4 to the exponent of 20, which is a lot. That's going to be equal to 1, 1, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. So in your calculator, what it's going to give you is it's going to give you this in scientific notation because the number is too big. So it's 1.1 times 10 to the power of 12, or 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't even know what that number is. That's huge. So that's how many ways you can answer a multiple choice exam with 20 questions, 4 possible answers for each question. And that's normally the size of a multiple choice test, roughly 20 questions. And usually there's about 4 choices. So you see that a lot of people don't do well on multiple choice exams. And this is why there's a lot of choices. Example 6. Let's say you are looking at telephone numbers in the United States. So remember, telephone numbers in the United States begin with a 3-digit area code followed by 7-digit local telephone numbers. So area codes and local telephone numbers cannot begin with the numbers 0 or 1. So how many different telephone numbers are possible? So sometimes I just put a blank for how many choices I have. So the area code is 1, 2, 3 choices. And the telephone number is 1, 2, 3, 4, 5, 6, 7. Each one of these spots has a certain number of choices. They are their own group. So there's actually 10 groups. So when you think about the area code, it cannot begin with 0 or 1. So 2 through 9 is okay. So there's actually 8 choices for the, now remember, we're not choosing the number 8. These are choices that you have in your group. So just to review the digits that we're looking at, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There's 10 digits. So I have 8 to choose from for the first number in my area code. But then for the remaining numbers in the area code, I have 10 choices. Now in the telephone number, it can't begin with 0 or 1, so that first number has to be 8 choices. But then I could choose any number for the remaining. So we're just going to multiply all of these together. Now the easiest way for me to do this without using a calculator is take the numbers that are not 10 and multiply those together. So I have 64. 8 times 8 is 64. And then when you multiply 10, that's just telling you how many zeros you have. So I have 1, 2, 3, 4, 5, 6, 7, 8 tens. So I'm going to have 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Let's see. So that's about 6,400,000,000 choices of telephone numbers in the United States. The question becomes, are we going to run out of telephone numbers? You know, everybody's got a cell phone now. It's not just a telephone for each home, it's a telephone for each person. Plus, some people also have telephones for their home. Businesses have multiple telephone lines. The population of the United States is roughly 330 million, and we have 6.4 billion telephone numbers available. So it looks like we're going to be okay. Example 7. So you notice these last few examples a little bit trickier. Example 7, let's say you have an electronic gate, and it's going to be opened by entering 5 digits on a keypad. The keypad contains the digits 0, 1, 2, 3 through 9. How many different keypad sequences are possible if the digit 0 cannot be used as the first digit? So again, I know I'm going to do a 5-digit keypad. So 1, 2, 3, 4, 5. For each number, I want to figure out how many choices I have. So for the first digit on my keypad, since 0 cannot be used as the first digit, then I only have 9 choices. So remember, it's not the number 9, it's 9 choices. But then I can use any number for the remaining digits on my keypad. So again, we simply multiply to get 9 with 4 zeros. So we have 90,000 choices. That's it for this section. Again, this section is just dealing with counting using the fundamental counting principle. In the next two sections, we're going to look at other ways that we can count using groups where maybe the order does matter, or maybe you're only choosing from one group and looking at how many ways you can make choices from one group. So those would be the next two sections. And that's it.